Hey grade 11s and welcome to this video. In this video, we will be working on the Mathematics Paper 1 for June 2025, and this is specifically from the Limpopo province. Okay, so this question paper is worth 100 marks and the time allocated is 2 hours. Just remember your instructions, okay? Just remember to round off to 2 decimal places unless stated otherwise, and the diagrams are not necessarily drawn to scale. Okay, with that being said, let's get into this paper. Question 1.1 says, if x is an element of 0, 2, 4, and 6, determine the values of x for which the square root of 8 over 4 minus x is undefined. Okay, so how do we get an undefined value if we are given this type of expression? We can see that we have a fraction there. And if the denominator of the fraction is equal to 0, okay, the numerator can be anything, even 0. But as long as the denominator is equal to 0, then your expression is going to be undefined. So we need to look at that denominator, which is 4 minus x. Okay, even if it's square rooted, it will still be 0. We just need to ensure that it is equal to 0. So for which x value is 4 minus x equal to 0? Because if this is equal to 0, the expression is undefined. So if we had to solve for x here, you see that x is negative. Transpose it, it becomes positive. So we just have positive x is equal to 4. Okay, and that would be our answer. As you can see, it works out. We do have an x value of 4 here. And that is our answer. Moving on to the next question. And then question 1.1.2 says we need to now find out the values of x for which this expression will be irrational. So irrational would mean that we would still have that square root. Okay, so it will be irrational once we simplify it. You can just try out your x values here. It's only 4 values, so we can just test this out instead of overthinking it and thinking, okay, instead of thinking about it like, we take 8 divided by a specific number, and we need to just ensure that that number stays a number that is not a square number, so that when you square root it, it doesn't simplify to a rational number, it stays irrational. Okay, so for example, if this ended up being something like when we say 8 divided by 4 minus whatever number we said, and let's say it just became 4, you see how it's not going to work here? Because the square root of 4 is 2, which is a rational number. We want it to remain irrational. So instead of overthinking it, just try out your x values. So if we tried out 0, okay, what happens here? Well, 4 minus 0 is still 4. 8 divided by 4 is 2. So square root of 2 cannot be square rooted, and then that actually makes it an irrational value. So 0 works. Let's try an x value of 2. So if this was equal to 2, you'd say 4 minus 2, which is 2. 8 divided by 2 is 4. But the square root of 4 is 2. So 2 does not work because it ends up giving us a rational number at the end of the day. This expression ends up being rational. If we tried 4, 4 minus 4 is 0, and you know that's not going to work. It's just going to make it undefined. Okay, and then if you tried 6, 4 minus 6, that's going to become negative, and 8 divided by a negative number would stay negative, and if you square root a negative number, you get a non-real answer. It's not irrational, it's non-real. So that wouldn't work either. So the only thing that works is when x is equal to 0. And that is our answer. Moving on to the next question. The next question, 1.2, says solve for x. And we have 1.2.1. We have a binomial. Okay, so an expression on the left-hand side with 2 terms. Meaning we cannot use trinomial factorization, but we can still factorize. Do you see that in the first and the second term, we have a common factor of x. So take x out as a common factor, and we have what is left in the first term, it's x. What is left in the second term, it's minus 4, and then is equal to 0. Okay, grade 11s, I know that it is tempting to just say, hey, we could just transpose that, and it's positive 4x. And say divide both hand sides by x. Never do this, because if x is equal to 0, your equation is undefined. So you cannot just cancel that x out like that. Okay, so as long as you don't know what that missing variable is, you can't just start dividing by it. Okay, so now that we have this, we are saying something times another thing gives us 0. The only way this equation will be true, where the left-hand side will be equal to the right-hand side, is if the first value we were multiplying by was equal to 0. Then you said 0 times whatever that was, and then it will give you 0. Or the second value we're multiplying by was equal to 0. So you said whatever x is multiplied by this value of 0, and then it will give you 0. So we would say either x is equal to 0 or this x minus 4 equals 0. And if you solve for x here, transpose the negative 4, x is equal to 4. And those are our answers. Moving on to the next question. Question 1.2.2 says we need to solve for x and we need to remember to correct to 2 decimal places. So this means this is a quadratic equation that we cannot manually factorize. We have to use the quadratic formula. So do you see that this is not in its standard form yet? And so we need to transpose this. So we have 3x squared, and so put it in the order of its exponents so it is in its standard form. So we have minus 5x and then minus 4 is equal to 0. And now it is in the form of ax squared plus bx plus c is equal to 0. So we can see that the value of a is 3, the value of b is negative 5, and the value of c is negative 4. Okay, quadratic formula, x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So x is equal to negative, and we have negative 5 plus minus the square root of negative 5 all squared minus 4 times a, which is 3, times c, which is negative 4, all over 2a, and that is 3. And substitute this, put this into your calculator and get your 2 solutions. So the first solution when we try plus is 2 point, and you see the 7 will round the 5 up to a 6. So 2.26, or x is equal to, and then we change that to a minus, and we get negative 0.59 rounded off to 2 decimal places. And that is our answer. Moving on to the next question. Question 1.2.3, we have an equation with a surd. Remember, this is for 5 marks, and regardless of whether it's for 5 marks or not, you still have to check whether your solutions that you get at the end are valid or not. Okay, so this is what we have, and the first step with equations with surds is to isolate the surd, but you can see that the surd has been isolated already. So all we have to do in this equation is to get rid of that surd so that we can actually solve for x. So to get rid of a square root, you square, but what you do on the one side, you must do on the other side. So this means we are squaring this. Remember, these are actually just being multiplied. That's why they're next to each other. If you said 2 times root x minus 3, it gives you 2 root x minus 3. So when they get squared, the 2 gets squared to become 4, and then this gets squared. If it gets squared, what happens is that radical breaks open and you just have the x minus 3. But this has 2 terms, so use brackets, okay, to show it's still multiplying to the 4. And then this is equal to, and we're going to square this. So you can decide to write this twice and then FOIL it out, okay, and multiply first, and then the outers and all that. Or you could just use a quicker method to avoid making any mistakes. So we can square the first term, that gives us x squared, square the last term, that gives us positive 9, then first term times second term, which gives us negative 3x, and then just double this, so multiply by 2, which is negative 6x. Okay, now distribute here, that is 4x, and that becomes negative 12 is equal to x squared minus 6x plus 9, and we can just go ahead and transpose this, so bring it over to the right hand side. 0 equals x squared, and if we have minus 6x, and then that comes over to become minus 4x, we get negative 10x, and then positive 9, this comes over to become a plus 12, we get positive 21. Okay, so now we have to factorize. So 0 is equal to, open up 2 brackets, this is a trinomial, x times x gives us x squared, and then we need factors of 21 that can give us 10 in the middle. Well, the factors of 21 that can give us 10, we can use 7 and 3. But notice how the middle is negative, but the last term is positive. So if you said positive 7 times positive 3, it gives you positive 21. But unfortunately, it's not going to give you that negative 10 in the middle. So we need to make this negative 7 and negative 3. That way, we say negative 7 minus 3 actually does give us negative 10. And when we multiply, they give us positive 21. So this is minus 7 minus 3. And let's solve. So x is equal to 7 or x is equal to 3. Okay, something times something gives you 0. It's either the first bracket is equal to 0 or the second is equal to 0. Okay, so these are two solutions, but we still need to test whether these are true or not. So you need to ensure that if you substitute them back into the original equation, the left-hand side actually is equal to the right-hand side. So let's try that out with 7. If x was equal to 7, we substitute 7 here and 7 here. Let's see. 7 minus 3 is 4. Square root of 4 is 2. And then 2 times 2 is 4. 7 minus 3 is also 4. You see how the left-hand side is exactly equal to the right-hand side? It means we can accept that solution. Let's go ahead and try 3 and see if it really does make the left equal to the right. So you can already see 3 minus 3 is 0. And then square root of 0 is 0. 2 times 0 is still 0. And 3 minus 3 is indeed 0. So in this case, they both work. They're both solutions. And we can accept both. And that is our answer. Moving on to the next question. Question 1.2.4 says we have an inequality and we need to solve x in this inequality for 6 marks. Okay, straight away, do you see how we have one hand side that is not equal to 0? Because of this, we're going to have to distribute. We can't just start equating because what are you going to equate it to? Okay, there's no 0 there. So we can't really find any critical values. So let's go ahead and distribute here. So when we multiply, x times x gives you x squared, x times 3 gives you positive 3x, and then you have minus 4x, which gives you negative x, and then in the middle we have negative 12. And we transpose that negative 6 to become plus 6 is greater than or equal to 0. So all we have is x squared minus x, and that becomes a negative 6 is greater than or equal to 0. Now we need to factorize this. So open up two brackets, it's still greater than or equal to 0. X times x gives us x squared. 6, okay, we need factors of negative 6. Negative 6, but they should give us negative 1 in the middle. We can try 3 and 2. So 2, 3, but then just make the bigger factor negative. That way it's going to stay negative. 2 minus 3 is negative 1. Okay, so positive 2 and negative 3. So to find the critical values now, okay, those points that mark where our solutions start, we are just going to equate this to 0. So it's like saying x plus 2 equals 0, therefore x equals negative 2, or x equals positive 3. And now that we have this, we can solve our inequality using our graph, or you can use the number line method. So look at this point, okay, so at the point where you had one hand side equal to 0. So at this point, do you see how we have this? And this creates a parabola, okay, because it's a quadratic expression that we have on the left-hand side. So it's going to create a parabola, but do you see that the coefficient of x squared, okay, the number in front of x squared, it's an invisible positive one. So because it's a positive value, it means that your parabola is going to be concave up, okay? So it is a concave up parabola or smiley face parabola. And we put down our critical values. So our critical values are negative 2, that's the smaller one, and the bigger one is 3. Okay, so they want us to find the values of x for which this graph is either greater than or equal to 0. So when you take x values and you substitute it into this, it's going to give you a result which is known as our y values. We can find out the type of y values we have looking at the y-axis. So they want y values that are either greater than or equal to 0. If it's greater than 0, these are y values that are positive, which lie over here. This is where you have positive y values. So that would be all the parts of the graph that lie above the x-axis. They would all have positive y values. And if we were looking for values that were less than 0, we would look below the x-axis. So we just know that we are looking above the x-axis in this case. But we need to ensure that we are solving for x for where this expression is always going to be greater than or equal to 0. Do you see that these critical values, okay, these are points where the y values are equal to 0. You can test it out. You can take this -2 and substitute it into this equation. You will get 0. Take 3 and substitute, you get 0 because they are the roots of this expression, the x-intercepts. Okay, so now let's go ahead and answer them. We need to look for parts of the graph that are above the x-axis. So highlight all the parts above the x-axis. That's over here and that's over here. And then we need to answer them in terms of x. So what are the x values that belong to these selected parts of the graph? Well, you can find the x values by lining it down to the x-axis. You see where these x values are? They are to the left-hand side of -2. So they are values that are either equal to -2, because you know that at -2, if you substitute, you do get 0. Okay, so values equal to -2 or less than -2. And we can just go ahead and say that here, x is simply less than or equal to -2. And we're done with that part. The second part here, let's line this down to the x-axis to understand where exactly these values are. There are values that are equal to 3 for the same reason as that. And then values that are, you see, to the right-hand side of 3. That's where these values, okay, these selected x values map to. So that's where x is greater than or equal to 3. And that is our answer. Moving on to the next question. Question 1.3 says, solve simultaneously for x and y. So this is a simultaneous equation and we need to solve. First, spot the linear equation, okay, because you can easily make something the subject there if, of course, you have a variable that has a coefficient of 1. Do you see that here we can make x the subject? So we can go ahead and call this equation number 1. This, by default, is equation number 2, and we will form equation number 3 by making x the subject. So x is on the right-hand side. If you leave it on the right-hand side, you just have to transpose the 1. So you have 3y minus 1. Okay, so this is equation number 3. And now to go ahead and solve, because this is x as a subject, we'll be solving for y. To solve for y, just take equation number 3 and substitute it into the equation you didn't use yet, equation number 2. So wherever you see x, replace it with 3y minus 1 in equation number 2. Okay, so we start off here, we have x. So we're going to substitute 3y minus 1. And then you still have minus y, and then multiply by 5y minus 3, and there's x again. So in place of x, substitute 3y minus 1, okay, is equal to 0. So this is what we have, and let's go ahead and simplify. So 3y and minus y gives us 2y. So this is just 2y minus 1, multiplied by, and this is 5y minus, and we can distribute in. So this is going to be negative 9y, and then positive 3 is equal to 0. And so 2y minus 1, and we have here 5y minus 9y is negative 4y, and then plus 3 equals 0. Okay, so you see that it has been factorized for you. Don't go ahead and start distributing. One hand side is already equal to 0, so you can start solving for y. So 2y minus 1 equals 0, or negative 4y plus 3 equals 0, and then 2y equals, we can transpose 1, divide both hand sides by 2, y equals 1 over 2. Okay, or here we can just transpose that, it's fine. So this is 3 equals positive 4y, and if you divide both hand sides by 4, then that just means that y is equal to 3 over 4. Okay, so we have solved for y, and now we need to still solve for x. Okay, so just take the equation that has x as the subject, which is equation number 3. X is equal to 3y minus 1. So we say x is equal to 3y minus 1, but in place of y, substitute this y value, okay, each y value. So we have 1 over 2. So find the x value that corresponds with this y value. That's going to be 3 over 2 minus 1. And 3 over 2 is 1.5, so minus 1 is just a half. Okay, or, and then second x value is 3 multiplied by 3 over 4 minus 1. Okay, so we're substituting this y value. So x is equal to, that is 9 over 4 minus 1, 1 can be written as 4 over 4. So 9 minus 4 is 5. So that is 5 over 4. And these are our answers. X is equal to a half and y equals 1 over 2. Or x is equal to 5 and y equals 3 over 4. And that is it for question 1.3. Moving on to the next question. Question 1.4 says, if x is equal to 8, is 1 root of x plus 48 over x is equal to 14. So this is actually a quadratic equation. It's just, you would have to simplify it further. So do you see that if you have this, and the x is just in the denominator, so we could remove it from the denominator by multiplying by x. But when you do that, if you multiply by x on this side, you have to do the same on this side. Okay, I'm just showing you that this is quadratic. It may not even be useful. So if you multiply in, you have x squared, and then you see the x there would cancel with that denominator, and you have positive 48 is equal to 14x. And then you see when you transpose it, you can see what we have now. We have a quadratic equation. So they're saying if x equals 8 is one of the roots of this equation, we need to determine 1 root of y for which, and they give us this equation. So find 1 root of y of this equation. When they tell you things like this, it just means that, you see, if you look at this equation and you look at that equation, you're going to notice similarities. So do you see how in this equation, we've got 14. We also have 14 here. We have 48. We also have 48 here. And then do you see that this has an x, but then this has a 3y minus 4. And likewise here. So you can see that x has just been replaced in this equation. So the question is to find a root of y, okay, if you know that x equals 8 is one of the roots of this equation, this quadratic equation. So we don't have to find the roots. This that I'm doing is unnecessary. I don't have to find any roots here. They've already given us one root. X is equal to 8 is one of our roots. So if we substitute 8 in place of x in this equation, then we know that the y value, okay, would be equal to 0. A root is an x-intercept. They're just saying if x is equal to 8, okay, is one of the x-intercepts that you have, then find the other root in this equation. Okay, so because the equations are identical, we're just going to look at this 3y minus 4 as x, okay? So if we knew that x was equal to 8, this was one root, then the root here would be found by saying, in place of x, just replace it with 3y minus 4, because that's what they did as well. They just replaced x with 3y minus 4. So it means the root in this equation would be found where 3y minus 4 is equal to 8 as well. Since it's identical, okay, the root was found where x was equal to 8. Therefore, the root will be found where 3y minus 4 is also equal to 8, since we have just replaced x with 3y minus 4. Okay, so this is what they're asking for, to solve for y. And we'll say 3y equals 8, and then plus 4 is 12. Then divide both hand sides of this equation by 3, and y is finally equal to 4. And that would be our answer. Okay, so 1 root of y, the root is 4 that we would have in this equation. And that is our answer, and that is it for question 1. Question 2.1 says, determine the value of, and we have this expression and it's written in exponential form. So we are subtracting this by this and then that by that. The best way to simplify this is to find a common factor, okay? Something common in the numerator that is also common in the denominator, because that number is going to be really big, but then it's going to cancel in the numerator and the denominator. And then we just have to work with smaller numbers. Okay, so that's what we need to do. Let's find out what's common. Okay, so the common factor would actually be 2 raised to the power of the exponent that has the lowest value, because then it would be common in every single thing. It would be able to fit into every exponent, really. Okay, so we can say that's 2019. We'll say 2 to the power of 2019. And if we took that out as a common factor in the numerator, what is left here? So that would be 2 to the power of how many more do you add to get to 2025? That would be plus 6. Okay, so 2 to the power of 6. If the bases are the same and you're multiplying, you would add the exponents. Okay, so this is what we have there. And then what we have left in the second term. From 2019 to 2023, that is 4. So that's minus first, and we have 2 to the power of 4. And there we go. And then all over, doing the same thing here. 2 to the power of 2019 is our common factor. And what are you left with in the first term? So from 2019 to 2021, what are we left with? That is 2 to the power of 2. And then minus, and you see this is just 2019. So what you multiply to 2 to the power of 2019 to get back to negative 2 to the power of 2019? Well, you multiply by negative 1. Okay, so there. You see how this big number that was so intimidating is now gone. And now we're just working with smaller numbers. Okay, then 2 to the power of 6 is, we're just going to simplify, that is 64 minus 2 to the power of 4 is 16. And then this is 2 to the power of 4, which is 4 minus 1, which is 3. Okay, so just simplify here. If we say 64 minus 16, we get 48. And 48 divided by 3 is 16. And that is our answer. Okay, all of that is equal to 16. So you see the trick with these ones. These numbers are really big. Just take out the highest common factor. Okay, that will be the lowest exponent between all of these. Okay, and that is our answer. Moving on to the next question. Question 2.2 says, simplify, and then 2.2.1, we've been given an exponential expression. So to simplify this expression, very similar to the previous question, it's exponential, so we're just trying to find common factors all through. So the way to find this is we could just separate these first. Okay, so we have 3 to the power of, and this is just x. And you can rewrite this as 3 to the power of x multiplied by 3 to the power of 4. Okay, when you multiply, you add exponents. Then here with the 6, we're going to have to break that up because the thing about 6 is it has a factor of 3. So we can rewrite 6 as 2 multiplied by 3, and then you have times 3 to the power of x plus 1. Okay, all over, and we have 7 times 3 to the power of x plus, and I'm just going to separate that as well, 3 to the power of 2, because I just want to see the common factor. You can see all through we have a 3 to the power of x. Okay, and at this point, we actually don't have to rewrite this like this. We can actually simplify this by leaving it like this. So we can actually just rewrite this as, we'll leave the 6 here, and then let's just rewrite this as 3 to the power of x times 3 to the power of 1. Okay, so we know that if you add the exponents when you multiply here, you get 3 to the power of x plus 1. Okay, so now we can finally take out the common factor. All through 3 to the power of x is common, so we can just take that out. 3 to the power of x comes out, and we are left with, in the first term, 3 to the power of 4. In the second term, we are just left with negative 6 multiplied by 3. That's what's left. And over, we still have 3 to the power of x, and then what is left is just 7 times 3 times 2. Okay, so that one, we're not really taking out a common factor. I'm just rewriting it differently. So these cancel, and now we are left with 3 to the power of 4, which is 9 times 9, 81. And we have 81 minus 6 times 3 is 18, over 3 squared is 9, 7 times 9 is 63. And now we just have to simplify this. Okay, so 81 minus 18 is 63, which is finally equal to 1. And that is our answer. And that is it for question 2.2.1. Moving on to the next question. Question 2.2.2 says we need to simplify this expression. Okay, so do you notice how we have a square root multiplied by a square root? Okay, if you say square root 2 times square root 3, you can actually write them under the same radical. So 2 times 3, because they're both square roots. In the same way, we can do the same thing here. We'll put this under the square roots, and what was under the square root gets multiplied. You can see that we have 2 terms. So this is first term, that's your plus sign, second term, okay, in that radical. So we have x plus the square root of 4x minus 4, and then multiplied by x minus the square root of 4x minus 4. Okay, and we have to simplify this. So under the radical, do you see how you have x, and then you have square root 4x minus 4 and square root 4x minus 4, but then you have a plus here and then a minus. So this is a result of factorizing an expression using difference of two squares. Meaning if you had to multiply them out, instead of doing that one by one, you could just remember that if you ever had k plus 4 times k minus 4, it's actually just equal to, you square the first term, or you just multiply the two first terms, k squared, and the two last terms, negative 16. Because you can see you have the exact same values here, it's just the plus and minus. So this is the result of factorizing this expression using difference of two squares. Okay, so what we can just do there is we're going to say to multiply them, we would just square the first terms. Okay, so x times x is x squared. And then square the last terms and then just keep a minus in the middle. So if you square the last term, 4x minus 4, and you square that, the radical breaks open. And so you're left with 4x minus 4. But you're subtracting by this, so you need to protect it with brackets. So this is what we have, and it's equal to, we have the square root of, we have x squared, minus, it multiplies into become minus 4x, and multiplies into become plus 4. And this is what we have. Okay, so we have to factorize this. I think I've seen this exact question before though. Okay, so just keep practicing past exam papers. You will notice many a time some things are repeated. It's still the same concepts they'll keep going through. Okay, so the square root of, and we're just going to say factorize that. X multiplied by x gives us x squared. And then we need factors of 4 that can give us a negative 4 in the middle. So since this is a positive 4, the only way we can get a 4 in the middle is by using 2 and 2. But do you see how only the middle is negative? So the only way you could have gotten a positive is by saying plus and a plus, okay? Positive 2 times positive 2. But you can clearly see they didn't do that because the middle is negative. So they must have said negative 2 times negative 2. That is the second way we could get a positive 4. So that is minus 2 and minus 2 and still square rooted. And you see that because it's the same thing times the same thing, if you had k times k, it gives you k squared. In the same way, x minus 2 times x minus 2 is x minus 2 all squared. And then you're square rooting this. And so it finally just becomes x minus 2. And that is our answer. And that is it for this question. Moving on to the next question. Question 2.3 says, solve for x. And we have 2.3.1. This is 5 to the power of square root x and then 125. What do you notice about 5 and 125? These are numbers that have a base of 5. Okay, they can be written as a base of 5. 125 can be. So we could rewrite this as 5 to the power of square root x. And then 125 can be written as 5 to the power of 3. That gives us 125. And now that the bases are the same, you see that to ensure that the left-hand side really is equal to the right-hand side, the exponents should be equal. So we'll just equate the exponents. So the square root of x is actually equal to 3. And then we still need to solve for x. So the square root of what is equal to 3? That is the square root of 9. Or you could just see this as square both hand sides of this equation. Therefore, x is equal to 9. That is what answers the question of square root x equals 3. Okay, square root what is equal to 3? It's the square root of 9. And that is our answer. Moving on to the next question. Question 2.3.2 says, we need to solve for x in this exponential equation. Okay, so you see with this one, unfortunately, unlike the exponential expression that we had, we can't really see something that we can say is common, just like common already. There is a common factor, but this is 5 to the power of x. This is 5 to the power of negative x. It's a little different. So if we look at 5 to the power of negative x, look at how we can rewrite this. The exponent is just negative. To make the exponent positive, we could move this 5, okay, from where it currently is. It currently is in the numerator. So move it to the denominator and then the exponent becomes positive. And then in the numerator, we still have 1. They don't switch places. This 1 is actually the placeholder of 1 here. It's actually the invisible 1 in front of 5 to the power of negative x. So now we can actually see a 5 to the power of x like that. So we could rewrite this as 5 to the power of x plus 15 and then multiply by, instead of this being 5 to the power of negative x, we can rewrite this as 1 over 5 to the power of x is equal to 2. Okay, and now we can multiply these. So this is 5 to the power of x, and that just gives us 15 over 5 to the power of x is equal to 2. Now you just see we have something repeating, 5 to the power of x and 5 to the power of x. At this point, you have the choice to use the k method by just saying whatever is repeating, let k be equal to it, and then you could solve for this. But it's not really that necessary. Here's the thing. You can see that to solve for x, right now, what is distracting us from solving for x? That would be this 5 to the power of x. So we can get rid of that by multiplying both hand sides by 5 to the power of x, just to get rid of that 5 to the power of x in the denominator. So this is 5 to the power of x. And now we have, now for the purpose of understanding and when we get to the factorization, let me actually just show you the k method. So let's actually just go ahead and say, let k equals whatever was repeating. That was 5 to the power of x. Okay, so if we rewrite this, we have k plus 15 over k equals 2. And so to solve for this equation, you see that the distraction, the first thing preventing us from solving for k would be this k in the denominator. So you'd multiply both hand sides by k, and let's multiply. So that's going to be k squared. This multiplies and cancels with that denominator of k. So plus 15, and then this is 2k. Okay, and then transpose. So this is k squared minus 2k plus 15 is equal to 0. Okay, and now we can factorize. So open up two brackets equate to 0. K times k gives us k squared. Factors of 15, that will give us 2. So 15 can be 3 and 5, so 5 and 3. See, in this case, this is not going to work because you can see that this is positive. So the only way we can get positive 15 is by saying positive 5 times positive 3 or negative 5 times negative 3. But the middle is negative, so you see it's going to have to be negative. So negative 5 minus 3 is negative 8, not negative 2. So that, we can't really factorize it. Let's check if we can actually use the quadratic formula here. So just say k equals and put the quadratic formula. You can actually find out whether you have roots or not by using this part, the discriminant. So if the discriminant b squared minus 4ac, if delta is a value that is either greater than or equal to 0, then you have real roots, meaning you actually have real numbers that are solutions to this equation. But if this ends up being a negative value, it's not going to work. So I'm going to actually just go ahead and check what exactly the discriminant is before jumping into finding this, because I have a feeling it's not going to work. It just looks, no, this is too big. It's going to make that second part too big. So if you substitute in here, we have negative 2 all squared minus 4, and then this is 1, and then this is c, which is 15. So this is equal to, that's 4. No, see, it's not going to work. Minus, if you say negative 4 times 15, you're going to get negative 60. And so 4 minus, you see, you end up getting a negative value. Unfortunately, negative 56 is negative. So this won't produce any real roots, meaning you're not going to have any solutions for k. And if you don't have solutions for k, you don't have solutions for x. So I think the problem here with this question was the sign that was used. I think this should have been negative, because if this was negative, then it would be negative all through. We would still have it being negative. Okay. And so you would have an expression that actually says k squared minus 2k minus 15 is equal to 0. And then we can actually solve for this. Okay, our factors would simply just be, we have k, and then we have factors of 15. That's going to be, you see with the 15, we could have just said 5 and 3, and this would actually work because it must be negative 15 at the end of the day. But then if you make the 5 negative and the 3 positive, the negative 5 plus 3 is negative 2. And there we get the middle coefficient. So minus 5 and then plus 3. So yeah, that was the problem here. This should have been negative if they actually wanted real solutions. But in this case, k would have no real solutions. Okay, and if k has no real solutions, therefore x will also have no real solutions. Okay, so you could still practice it by making that negative, and then we would solve for k. So I'll just go ahead and do that. Let's solve for k here. We would see that k would be equal to 5, or k would be equal to negative 3. And if we knew that k was equal to 5 or k was equal to negative 3, we would have to solve for x. Remember that this equation was a solve for x question. At some point, we just said let k equal 5 to the power of x. So we would replace that. So 5 to the power of x, we'll put that back in place of k, is equal to 5. And you see here, to ensure that the left is equal to the right, the bases are already the same, just equate the exponents. The exponent here is 1, so x would be equal to 1. Okay, and then here, we would just say 5 to the power of x is equal to negative 3. But you see the problem with this? You're taking 5 and you're raising to an exponent, and it gives you a negative value. That's not possible. Okay, if you take 5 to the power of 1, it gives you 5. Negative 1, it gives you 1 over 5. Negative 2, it gives you 1 over 25. It's never going to give you a negative number. Okay, so in this case, it wouldn't work. So we'll just say here, x has no solution. And that's what they probably intended to happen. But because of that sign that was positive, it didn't work. Okay, so you could still practice by making that negative. And that is it for this question. Question 3 says, given the function f of x is equal to 4 over x minus 2 plus 4 and g of x equals 2 to the power of x minus 2. Write down the equations of the asymptotes of f. Okay, so f is a hyperbola, and you can see that it is in the form of y equals a over x minus b plus q. Remember that a hyperbola has two asymptotes. It has a vertical and a horizontal asymptote. The vertical asymptote, that would be your value of p. Okay, so you can see that it's 2 there. And remember, it's a vertical line. So it's a line that has one particular x value. It cuts the x-axis at one particular point, that is 2. So its equation is x is equal to 2. And the horizontal asymptote is that q value. So it is y is equal to, because it's a horizontal line, and it cuts one particular y value, and that is that y value of 4. So those are the equations, okay? X is equal to 2 and y is equal to 4. That's the vertical, that's the horizontal, and that is our answer. Moving on to the next question. Question 3.2 says, calculate the x and y-intercept of f. Okay, to find the x-intercept, you just simply make y equal to 0. So let's go ahead and take f and make y equal to 0. Remember that f of x stands for y, so in place of f of x, we say 0 equals 4 over x minus 2 plus 4. And let's go ahead and solve for x. So to solve for x here, you can transpose the 4. So it's negative 4 equals 4 over x minus 2. And then this is a fraction. You can make that a fraction by putting it over 1 and cross multiply. So 1 times 4 just stays 4. And then we'll say negative 4 times x minus 2. So because it's 1 term times 2 terms, you have to say negative 4 times the x is negative 4x. Negative 4 times the negative 2 is positive 8. And now we can transpose this to make it positive 4x is equal to 8, and transpose the 4 minus 4, which gives us 4. Divide both hand sides of the equation by 4. Therefore, x is equal to 1. Okay, so that is our x-intercept. X is equal to 1. And so to find the y-intercept, we simply make x equal to 0. So in place of x, substitute 0. We have f of x, I'll say f of 0. So where I see x, I substitute 0. And that is 4 over 0 minus 2 plus 4. And let's go. So f of 0 equals, if you say 0 minus 2 is negative 2, 4 divided by negative 2 is negative 2. Then plus 4, 4 minus 2 is equal to 2. And that is our answer. So x is equal to 1 and y equals 2. And those are our answers. Okay, x-intercept and y-intercept. They're probably going to ask us to draw this graph at some point. Okay, moving on to the next question. Question 3.3 says, write down the domain of f. So the domain refers to all the possible x values of a graph. So the graph of f is a hyperbola. And with the hyperbola, remember we know the vertical and horizontal asymptote, x equals 2, y equals 4. So if we have this graph and we know the vertical one is x is equal to 2, right? And the horizontal is y is equal to 4. But we're looking at the domain, which is all the possible x values that this graph has. You see a hyperbola, regardless of what it looks like, whether it's in the first and the third quadrant or the second and the fourth quadrant. This hyperbola, if it has an asymptote of x is equal to 2, all the x values that exist for this graph, you see that, let's just say this wasn't here. Let's just say it looked like this, which it actually does, because you see that they said the value of a here, right, is 4. So when a is positive, it lies in the first and the third quadrant. When it's negative, it's in the second and the fourth quadrant. So in this case, do you see how this graph would have every single x value, almost every x value? See, it has this x value over here. This point over here, it lines up to this x value. This point lines up to this x value. And this would keep going, okay? And just moves closer and closer to the asymptote. This point over here has this x value, and this one has this x value. It has x values all through, except for one place, okay? And this is where we have our asymptote. So it has every other x value except for at that asymptote, meaning we'll just say x is an element of all real numbers, but x is not equal to 2. And that is our answer. Okay, so that's how the domain works. It will work the same for the range. Okay, the range is just all the possible y values, and you have to think about where it will not have a y value. And that is our answer. Moving on to the next question. Question 3.4 says, determine the equation of the axis of symmetry of f, which has a negative gradient. Okay, so a graph, a hyperbola, we know that this one looks like this. Okay, there are two axes of symmetry that it has. It has one with a positive gradient and one with a negative gradient. And this is the one we're trying to find. If we have the one with the positive gradient, its equation is very simple. If you remember the general form of your hyperbola, a is equal to x minus p plus q, then you remember this. It's actually x minus p plus q. So that's the one with a positive gradient. As you can see, the coefficient of x is a positive invisible 1. Now, if it was the one with a negative gradient, to find this, all you do is just put a negative in front of the x minus p. So you have x minus p, and you put negative there, and you still have plus q. So this is equal to negative x plus p and then plus q. And that would be the equation with the negative gradient. We would just have to substitute p and q. So y equals negative x, and what is p? You saw that the value of p is 2 and the value of q is 4. So y equals negative x plus 2 plus 4. And so the equation of that axis of symmetry is negative x plus 6, and that is our answer. Moving on to the next question. Question 3.5 says, calculate the x and y intercept of G. So just take the graph of G, find the x and y intercept the way we did with the graph of f. Okay, so to find the x intercept, you're simply going to make y equal to 0. So if this was 0, g of x is 0, and then you have 2 to the power of x minus 2, then you can just transpose this to make it positive 2. So 2 equals 2 to the power of x. And finally, x is equal to 1, okay, because the exponents would be equal. And to find the y-intercept, you would just make x equal to 0. So we have g of 0 equals 2 to the power of 0 minus 2. G of 0 equals 2 to the power of 0. Anything to the power of 0 is 1. So 1 minus 2 is negative 1. Okay, so the y-intercept here is y equals negative 1. X-intercept is x equals 1. And that is our answer. Moving on to the next question. Question 3.6 says, write the equation of the asymptote of g. Now you see that g is an exponential function. Okay, it's in the form of y equals a times a base raised to the power of x, and then minus p, because sometimes there's a shift, and then plus q. Now this q value, that's what tells us the asymptote. just remember that the asymptote, okay, of an exponential function, it only has one. It doesn't have two like the hyperbola, because an exponential function can either look like this, it could look like that as an increasing, and then it has an asymptote somewhere here, or even, a negative one. Or it could look like this. It could also look like this. So in this case, its asymptote would be above the graph. And it could also look like that. Asymptote is still above the graph. So the equation of that, as you can see, that asymptote was always like that. It's a horizontal asymptote. And you saw with the hyperbola, the horizontal asymptote starts with y is equal to. So it's y is equal to this q value. Okay, you see how it's still q? They just make it simple by assigning the same letter so you always remember it across your other graphs. So it is y is equal to -2. That is the equation of our horizontal asymptote of g. Moving on to the next question. Question 3.7 says, sketch the graphs of f and g on the same system of axes and then show all intercepts with axes and the asymptotes. So just show all intercepts and the asymptotes. Okay, so let's put down a Cartesian plane first. And we can start with the graph of f, okay, the first graph, the hyperbola. So we know that the hyperbola is going to lie in the first and the third quadrant because the value of a was +4, okay? And we also know the x and y intercept. But the best way to sketch the hyperbola is by actually putting down your asymptotes so you know what not to go beyond, okay? The line you shouldn't pass when drawing it. So we have x is equal to 2 as the vertical and y is equal to 4 as the horizontal. So we'll just put those down. X is equal to 2 as the vertical asymptote. I'll just put that here. And make sure you put down x is equal to 2, or at least show that it passes 2 on the x-axis. And then y is equal to 4. So y equals 4. I'm not really going to draw them according to scale. So let me just move this to the left. Okay, so y equals 4. I'll just put that here. So that is y is equal to 4 and it passes 4 on the y-axis. And then we can go ahead and put down our points. So for the hyperbola, we know that the x-intercept was at 1, the y-intercept was at 2. So x-intercept, this is where it intersects the x-axis at 1. So 1, I'll just put that there. And then it intersects the y-axis at 2. And we knew that the hyperbola, because a was greater than 0, it lies in the first and the third quadrant. So our graph would look like this. You can see that in the third quadrant, this is where we have this part of the hyperbola. It goes like that, passes 1 and 2, and then moves closer and closer to the asymptote, never touching it. Okay? And then you can just draw the other wing and just mimic what that one was doing. Copy what that was doing. So something like that. That's fine. Just make sure that it moves closer and closer to the asymptote. Okay, so this is our graph of f, and we're done with that. And now let's go ahead and draw the graph of g. So with the graph of g, we only have one asymptote, a horizontal asymptote, because this is an exponential function. And that asymptote was at -2. So y equals -2. So we just go -2, and we put a line down. So we say y equals -2 there. And then let's look at this exponential and just figure out a few things. We know the x and y intercepts, we can just put them down. This is x is equal to 1 and y equals -1. So the x-intercept is at x equals 1. Also intersects the same place as this x-intercept of the hyperbola. And then y equals -1. So it intersects the y-axis at -1. So somewhere around there. Yeah, I made these way too small. I should have actually just been generous with the space. Okay, but that is -1. And so here's how your graph is going to look. You have to look at what this graph is doing. So it's really just this part that will tell you everything. You have to figure out whether it lies above the asymptote or not, and whether it's increasing or decreasing. So with that 2 to the power of x, it will tell you everything. With 2 to the power of x, you can see that because it's in the form of y equals a times b to the power of x minus p, right? The value of a is actually an invisible 1. If it was negative, you'd see a negative here, but it's positive. So when a is positive, greater than 0, it means that your graph lies above its asymptote. So it could look like that, or it could look like that. That's what the exponential function would look like. Now, to decide on whether it's actually increasing or decreasing, you would look at these together. So just check what 2 to the power of x is doing. Is it generally increasing or decreasing? You can test it out using two x values that come right after each other. So x is equal to 1 and x is equal to 2. If you substitute 1 in place of x here, you get 2 to the power of 1 and you get a y value of 2. If you substitute 2 here, you get 2 to the power of 2, which is 4. Now from 2 to 4, did we increase or decrease? We increased. So it means that this exponential function simply looks like this. It is an increasing function that lies above its asymptote. And that's how you decide that. So from this, you can see how this is the asymptote. This is -1, this is 1. So it's going to go from being really close to its asymptote. It's going to pass -1, hit 1, and then it just shoots up. Okay, shoots up like that. And that's what it looks like. So not the best looking graph because I didn't really plan out those numbers well. But that is what our graphs would look like. Okay, two graphs, and we can see we have a point of intersection over here at 1. And that is our graph. And that is it for question 3.7. Question 3.8 says, determine the values of x for which f of x is greater than or equal to g of x for where x is less than 2. So we're looking in the section where x is less than 2. So when we're looking at this, you see here's 2. This is the x value of 2. This is where x is greater than 2. All of these places, these are x values that are greater than 2. And then this is where x is less than 2. So they're saying where x is less than 2, find out where f of x is greater than or equal to g of x. So we are only looking here. So in this section. Where is f of x greater than or equal to g of x? When they are referring to f of x, they're referring to the y values of f and g of x, the y values of g. So where do we have y values of f that are greater than or equal to the y values of g? Well, that can only happen when the graph of f is above the graph of g. Okay, because let's say they look like this. This was f and this was g. You can see that if you had to put a Cartesian plane down, that the graph of f, for example, over here, and you look at it for the same x value. Okay, so for this same x value of whatever this is, let's say this was 3, right? Oh, let's just be realistic. Let's say this was -1. Okay, so I'll just put the y-axis over there. Let's say this was -1. You see that the graph of f has a higher y value than the graph of g. So that's what they're asking for. Where does f have higher y values than the graph of g? And of course, where are they also equal? So within that interval. So we're just looking for in this region, where is f, the blue graph, above the red graph? You can see it's above it all through. Okay, see, the graph of f is above g all through here. Okay, and then where are they equal? They intersect at 1. So you can clearly see this is starting at 1 and it is within the region where x is less than 2. Okay, and then it's everything all through here. So you need to answer in terms of x. If you line these up to the x-axis, you can clearly see these are x values that are either equal to 1 or less than 1. Okay, so there. That was our answer over there. After this, unfortunately, you see how the graph of g is now above the graph of f. So we can't take that. But we can take all of these. Okay, so this is where x is less than or equal to 1. So x is less than or equal to 1 is our answer. Moving on to the next question. Question 3.9 says, the graph of f has undergone transformation to form the graph of h. Okay, determine the horizontal asymptote of h. So the horizontal asymptote, but they have written it in this format. Okay, so to find the horizontal asymptote, we need to ensure that, remember this is a hyperbola, and we know that because, it comes from f, but you can see it's a hyperbola because of that denominator. So to get it so that it is written in the form of y equals a over x minus p plus q, this is what we need to do to it. So we're going to form a 1. And how we're going to form a 1 is by using this denominator of x minus 2. So rewrite this as h of x is equal to, in the numerator, we are going to write x minus 2. but it still needs to maintain what this was actually equal to, which was x plus 2. So if you had x minus 2, what do you add or subtract to this to get it back to x plus 2? So just focus on the 2, okay, and the negative 2. Negative 2, how do you get negative 2 to become 2? You do this by adding 4. So this is actually x minus 2 plus 4. And then it's still over x minus 2. We have not changed this, we've just changed the way it looks. It's still x plus 2 if you simplify that. And now we can separate it like this. So h of x is equal to, and we're going to take this and put it over. So we're going to see this as one separate term and then added to the 4. So we will separate these and write them under the same denominator, separate denominators, but the denominators are still the same. So we have x minus 2 all over x minus 2 and then plus 4 over x minus 2. Okay, we just separated them. So finally, h of x is equal to, you can just rewrite this, and that is just 4 over x minus 2. And x minus 2 divided by x minus 2 is positive 1. So you can see from this, if it is written in the form of y equals a over x minus p plus q, that horizontal asymptote is 1. So y is equal to 1 is the equation of your horizontal asymptote, okay, in your hyperbola. That horizontal asymptote is y equals 1. And that is our answer. Moving on to the next question. Question 3.2 says we need to now describe the type of transformation from f to h. Okay, so let's look at the graph of f and just remember what that looked like, and then we compare it to h, and then we'll understand what happened. So this is the graph of f. F of x is equal to this, and then h of x, we saw what this is now equal to. So what did they do? You can see the 4 is still the same, okay? This is still the same. The only thing that is different is this 1 and this is 4. So it used to be 4 and then now it went down to 1. So what did they do? You see that 4 is the horizontal asymptote of the graph of f. So if that is what the horizontal asymptote used to be, okay, the blue graph, it used to be 4, but now it is 1, then what did they do to this graph? If it went from 4 to 1, it means they shifted this graph down by 3 units. Okay, if you go 4 and you go 3 units down, you get to 1. So that's what happened there. This graph was shifted, f was shifted 3 units down to obtain h. And that is our answer. And that is it for question 3. Question 4 says, the diagram below shows the graph of f of x, which is a parabola, and it's a concave down parabola, and g of x, which is equal to mx plus q, which we can see is a straight line. D is negative 1 and 4, and F are points of intersection of F and G. T and U are x-intercepts of F, and we have E, which is 0 and 6, that is the y-intercept of F, and S is the x-intercept of G. VW is a straight line parallel to the y-axis. Okay, so question 4.1 says, write down the equation of the axis of symmetry of F. Okay, so this question, they're really just tackling your understanding in graphs and really understanding each graph. So the hyperbola, the exponential, the parabola. So with the axis of symmetry, this is the line that divides this graph symmetrically. And so to cut this graph, the parabola, into 2 equal parts, you have to divide it right from this point, the turning point. And so you see that the axis of symmetry is this vertical line. And because it's a vertical line, it starts with x is equal to. And we can see that it is x is equal to whatever the x value of that turning point is. Okay, so can we actually see it? We can't see it with this, but have they given us anything that can help us see it? Yes, they have. So they didn't really give you the x-intercepts. However, they have given you something to help. You see this point E and F? Notice how they both have the same y value. That means that if you had to draw a line using E and F, it would create a horizontal line. And so because we have this horizontal line with 2 points on the graph of f, then if you found a middle, right? Right in the middle, you would see that that would be the x value of your turning point. And this is really just because of the symmetry of a parabola. What the parabola does on this side, it does the exact same thing on this side. So if this is the axis of symmetry, then from this line to this point, it will be the exact same distance as from this line to this point of E. Okay, so just find the midpoint of this, the x value's midpoint really. So we will just say, to find this, we'll say x is equal to, and we take the x values there, it's 0 and 1. So 0 plus 1 divided by 2. And so that is x is equal to 1 over 2, and that is our answer. Moving on to the next question. Question 4.2 says, for which values of x is f increasing? So tell them the values of x where you see the graph of f is increasing. So the graph of f does two things because it's a parabola. If you look at it starting from this side, look at what this graph is doing. It is moving up, so it's increasing. And then once it reaches the turning point, it turns and then it starts to decrease. So we can see that the section where it's increasing is over here, and we need to answer them in terms of x. We know that where it takes a turn is at that turning point, and the x value is 1 over 2. So where the graph is increasing would be all these values. If you line them down to the x-axis, they are values that are less than 1 over 2, and that is our answer. We'll just go ahead and tell them this is where x is less than 1 over 2. I won't say equal to 1 over 2 because this 1 over 2 is the point where it actually makes that turn. It's not increasing at that point, it's just standing still. Okay, and that is our answer. Moving on to the next question. Question 4.3 says, calculate the average gradient of f between D and E. So the average gradient of f between D and E. So just take the point D and the point E, and we're just going to find that average gradient. So the average gradient will be found by saying this gradient is equal to, and we'll say the y2 minus y1 over x2 minus x1. So the second point, we can take that as E. So that is 6 minus 4 over 0 minus negative 1. And so 6 minus 4 is 2, and then 0 minus negative 1 is plus 1. So that is going to be 2 over 1, which is just 2. And that is our answer. Moving on to the next question. The next question says, determine the equation of G. So let's see what we have and how we can actually find G. So the equation of G, do you see that the graph of G passes 2 points? It passes D, negative 1 and 4, and F. So we can actually use those 2 points to find the equation of this straight line. So let's put down D and F. So to find the equation of the straight line, we first need to find its gradient. We saw from the previous question, to find gradients, we'll just say y2 minus y1, so 6 minus 4, over x2 minus x1, which is 1 minus negative 1. And so this is 2 in the numerator, and that becomes 2 in the denominator. So the gradient is 1. And then to find the equation, you can use y equals mx plus c, or you could use this. I'll just use y minus y1 equals our gradient times x minus x1. And so just pick 1 point on this graph of G. I'll take f because everything is positive here, and we substitute it into this equation. So this is x1, this is y1, and we have our gradient. So we'll say y minus y1, which is 6, is equal to our gradient of 1, and then x minus x1, which is 1. And so if you multiply 1 times anything stays the same, so this is x minus 1, and so we can transpose the negative 6. Y is equal to, and then we have plus 6, y is finally equal to x, and that just gives us positive 5, and that is the equation of G. So they probably wanted it written as G of x because they didn't say write it as, y is equal to. So G of x is finally equal to x plus 5, and that is our answer. Moving on to the next question. Question 4.5 says, show that f of x is equal to, and this is what it's going to be equal to. So we need to find the equation of f. Okay, so with f, let's see how much points we have here. you see that the graph of f passes 3 points. So D, F, and E. But E is a special point. This intersects the y-axis, so that is a y-intercept. So because of that, you see that it was written in the form of f of x equals x squared plus bx plus c. C is the value of your y-intercept, and so we know that is 6. We can actually we can sort it out like that. It's fine. We could have also used turning point form if you wrote the equation of your parabola in turning point form as a and then x minus p all squared plus q. Then remember that you actually have the x value of the turning point. That is a half. If you had substituted that in there, you see that all that is missing is a and q, and then you could just use those 2 points to find it. So you first substitute that first point, get your equation, second point, get your other equation, and then you make something the subject in both. Probably q. It'll be easy to make the subject. Okay, so that's another way. So it's not only one way to find this, but we can just use this method because it just seems simpler since we would have something filled in for C. Okay, so I'm going to put those 3 points down, and we know now that f of x is currently equal to ax squared plus bx, and now we know that the value of C is 6. Okay, so I'm just going to tell them I know that C is 6 because this is the y-intercept. And now, because we've used this, we can just focus on these two. We're going to substitute these points into this equation. You can see that only 2 things are missing, meaning 2 points are enough to find it. So substitute -1 and 4 first, and we would get 4 as our y value is equal to a multiplied by, and then x is -1, all squared plus b times -1, and then plus 6. And then here we would substitute 1 and 6. So in place of y, we substitute 6 is equal to a times 1 all squared plus b times 1 plus 6. Okay, so this would become, we have 4 is equal to -1 squared is 1 times a is still a. And then this becomes minus b, and this is plus 6. We can transpose that. We can just, make something the subject. I can see that it's better to work with both of them, so you just see what you can make the subject here. This is 6 is equal to, this is a, that is plus b, plus 6. Okay, so a or b could be your subject, and it will be perfectly fine. So I'm just going to leave a on this side and then transpose everything. So this is 4 minus 6, which is -2, and then take the b over, so it's positive b minus 2, okay, is equal to a. And then over here, I'll also leave a on the right-hand side and then take everything else over. You see that if you say 6 minus 6, it's just going to cancel. So that's 0. And then b comes over to become -b. So these are the 2 equations we have. They both are equal to a, so we can equate them. A is equal to a, therefore b minus 2 equals -b. Transpose this -b, you have 2b now is equal to positive 2. Divide both hand sides by 2. B is equal to 1. Okay, so we found B, and now we can find A. So just use the easier equation. This one is easier. A is equal to -b, so A is equal to -b, which is 1. So -1. A is equal to -1. And so these are our values of A, B, and C. And finally, f of x is equal to ax squared. Well, A is -1, so -x squared, plus bx, so plus x, and then plus c, which was 6. And that is our answer, -x squared plus x plus 6. And there we go. Moving on to the next question. Question 6.4 says, determine the range of f. So the range. The range refers to all the possible y values of a graph. So if we know that the parabola's equation is now this, think about what it looks like. It is a concave down graph, and I don't even need to look at it from there. We can just look at it from here. We know that it forms a concave down parabola. And with this parabola, which actually looks like this, okay, with this parabola, you see that all the y values that exist for this parabola, look at where they are. If you look at various points, like this point has a y value over there, this point has a y value over there, you see that all through it's going to have y values for all the points that lie on this graph, except for everything above this turning point, because it's a concave down parabola. you see that you will not have any y values here on this side. Okay, so find out exactly what the y value of the parabola is, and you know that you won't have y values up here. So all the y values that exist for this graph would be whatever that y value is and everything less than that y value. Okay, so let's find that y value of the turning point. We don't have to look for the x value of the turning point because we already have it. We found that in the first question to be 1 over 2. Okay, the x value of our turning point is 1 over 2. The equation of the axis of symmetry of this parabola is 1 over 2. So just substitute 1 over 2 to find the corresponding y value. So that will be the y value of the turning point. So negative and then 1 over 2 all squared plus 1 over 2 plus 6. And so f of 1 over 2 is equal to, and let's get our answer, and that is 25 over 4, or we could say 6.25. Okay, so that means that all the y values that exist here, since we know that the y value of the turning point is 6.25, it will be values less than 6.25 and equal to 6.25 as well, because we have an actual point with a y value of 6.25. So its y is less than or equal to 6.25, and that is our answer. Moving on to the next question. Question 4.7 says, calculate the length of SU. Okay, so to find the length of SU, you can see that this is just a way of them asking us, find the x-intercept of the graph of G and then find this x-intercept of the graph of F, and then you would know what SU is. Okay, so let's find the x-intercepts. Okay, so I've just added this image here, and let's just go ahead and use the equation of the parabola first to find the x-intercepts, and then we'll just choose the one that corresponds with U. Okay, so to find the x-intercept, we need to make y equal to 0. So we'll make this equal to 0, and you can see that these are, well, the coefficient of x squared is negative, so we can just transpose everything to make it positive. Positive x squared minus x minus 6 equals 0. Open up two brackets, equate to 0. X multiplied by x gives us x squared, and then factors of negative 6, that can give us negative 1 in the middle. It has to be 3 and 2, but then the 3 should be negative, and the 2 should be positive because negative 3 plus 2 is negative 1. So minus 3 plus 2, therefore x is either equal to 3 or x is equal to negative 2. Now, which one belongs to U? Because U is more to the right and it's positive, it is the positive 3. So it is U, use 3 and 0. So we know what U is. Now all we need to find is S. Okay, so find S and we'll use the graph of G, which we already found the equation of. Okay, so this is G. G of x is equal to x plus 5. And we're trying to find the x-intercept. So we make y equal to 0. And you see, you just need to transpose 5. So it becomes negative 5 is equal to x. And so there we go. X is equal to negative 5, meaning that the coordinates of S are negative 5 and 0. So it means that this line SU, the length of this line, look at what it looks like. Because you know this is negative 5 over here. This one is 3. It means that from the origin, you went exactly 3 units to the right to get to U, and then 5 units to the left to get to S. So the full length would be that 3 units plus the 5 units, which is a total of 8 units. And that is our answer. We'll just tell them SU is equal to, you can say 5 plus 3, which is equal to 8 units. Okay, moving on to the next question. Question 4.8 says, determine the values of x for which f of x minus g of x is less than or equal to 0. Whenever you see that going on, okay, they're subtracting, just transpose this. It's actually negative, so take it over and so it'll become positive g of x. So the question is, where is f of x less than or equal to g of x? Now, you would have seen from the previous questions, okay, in question 3, you would see that when we're trying to find out where f of x is less than or equal to g of x, you're simply trying to find out where the graph of f is below the graph of g, because now it's less than or equal to. So where does f have lower y values than the graph of g? So let's look at this. The graph of f is the parabola. Where is it lower than the graph of g? Or where is it below g? Over here, the graph of f is above g, all through. It's just above it. But then here, this is where it's below it. Do you see how f runs below the graph of g? And over here, f is also below the graph of g. So we need to ensure that it is less than or equal to. So at these points, this is where they intersect. This is where they are equal. Okay, so this would be our answer. We can see the point of intersection is -1. So this starts where x is equal to -1. And then it works for all the values here, which are less than -1. So we can see that is where x is less than or equal to -1. Or, and then the other part that we have selected is here. We can see where they intersect, where they're equal, is at 1. And so it is values that are equal to 1 and greater than 1, because all of the parts selected, they are on the right hand side of 1. So all of these over here. So this is where x is greater than or equal to 1, or x is greater than or equal to 1. And that is our answer. Okay, and that is it for this question. Moving on to the next question. Question 4.9, the last question for question 4 says, calculate the maximum length of VW. Okay, so the maximum length. Let's look at where VW is first. VW is this over here. And you can see with VW, it is at a point where the graph of F is above the graph of G. But they didn't really tell us the x value, so we can't really assume anything. So to find that maximum length, to find the length naturally, if you had these points, you would take the y value of f. Okay, so there, that whatever that y value is, you'll take that y value of f, and you would say, okay, I want to find the length, so let me find the y value of g, since w lies on g. Okay, so you're just taking them depending on the graph they lie on. V lies on f, so it's y value, and this it's y value. And if you subtract them, you'll get the length. So we will find the length first, and then we will find out the value of x at which it is a maximum, and then actually find that maximum length. So it all starts with finding the length of it. So we have to take f of x, the y values of f, and minus by the y values of g, because we don't actually have an x value here. They didn't tell us what the x value is that belongs to these 2 points. So to find the length first, so VW, a general length would be found by saying f of x minus g of x. Okay, so let's take our graphs and subtract them. So that is this minus the graph of g, which we already had. So minus, and the graph of g, remember that was x plus 5. So minus x plus 5. So this is VW. VW is finally equal to negative x squared plus x plus 6 minus x minus 5. And if you simplify, it is negative x squared. And then these, they would cancel, okay, because it's positive x and negative x. And then 6 minus 5 is positive 1. So this is the length of VW. Notice how the length of VW is in the form of a quadratic expression or equation. So with this, we can actually create a graph. All the y values of this graph would tell you the length, and it's a concave down parabola. As you can see, the value of a is negative. Okay, all the y values tell you the length of VW at different x values. Okay, so for example, here, let's say x was equal to -1. It's showing you that the length or the y value that corresponds with this is this y value over here. And then over here, and so on. So what we're trying to find is that maximum length. So to find the maximum length, because this is the graph that describes the length of VW all through, we have to find out what exactly this y value is, okay, at the maximum, because this is the highest that this parabola would ever reach. So let's go ahead and find the y value of this maximum point over here. And we can find that, well, this is already in a very simple form. You can see that we have negative x squared plus 1. In grade 10, this is what the equation of a parabola would look like, where this 1 stands for your y value of your turning point and also your y-intercept. So it means that y value of our turning point, that is actually 1. So we can see that the maximum is 1. The highest length that we will have on that line VW is 1 unit. And so we can finally show them y is equal to 1. Therefore, the maximum length is 1. You can go through the whole step of finding the x value of the turning point, but you can also do it by observation. You can actually tell them, I know that the x value of the turning point is 0. Okay, if you use negative b over 2a, negative b, there's no b value here, so it's 0. Negative 0 over 2 divided by anything, as long as it's not 0, of course. And we can see that the value of a is negative 1. This will still give you 0. Okay, so you can put that there, but I know that x is equal to 0, therefore y is equal to 1. Okay, so we can finally show them that the maximum length of VW is 1 unit. And that is our answer. And that is it for question 4. Okay, so that is the last question for this paper, and that wraps it up for this paper. I hope you guys enjoyed it, and I hope to see you in paper 2.